When two ratios are equivalent, they are called proportional. Proportions are an important application of ratios that allow you to solve a number of real-world problems. In this video, we look at examples of finding proportions based on equivalent ratios. Let's look at an example. A certain juice drink has 2 parts lime juice to 3 parts orange juice. The pitcher has 4 pints of lime juice and 6 pints of orange juice. The glass has 8 ounces of lime juice and 12 ounces of orange juice. Do they have the same mixture of juice? There are 2 ratios that we're analyzing: the mixture of lime juice and orange juice in the pitcher and in the glass. For the pitcher, the ratio of lime to orange juice is 4:6. As a fraction, this simplifies to 2/3. For the glass, the ratio of lime juice to orange juice is 8:12. As a fraction, this also simplifies to 2/3. This means that 4:6 and 8:12 are equivalent ratios, and they form a proportion. Make a note that the original ratio for the juice drink has 2 parts lime juice to 3 parts orange juice. So each of these individual ratios is also proportional to the recipe. This means that the concentration of lime to orange juice is identical from the pitcher to the glass. Testing for equivalent ratios is one way to see if there's a proportion. Sometimes you'll need to create a proportional amount based on an initial ratio. Let's look at an example. To make concrete, cement is combined with 2 parts sand to 3 parts gravel. If 36 pounds of gravel is available, how many pounds of sand are needed? The ratio of sand to gravel is 2:3. We want to find the proportional amount that has 36 pounds of gravel. To solve this, we can use a ratio table like this. In the first column, we write the names of the items: sand here, and gravel here. In the second column, we write the basic ratio of 2:3. In the third column, we know we want 36 for the gravel. Now look at the values of 3 and 36. By what factor do you need to multiply 3 to get 36? It's a factor of 12. So we use that same factor to scale up the amount of sand. So 2 times 12 is 24. So we need 24 pounds of sand. Another common application of proportions is with recipes. Let's look at an example. A recipe for meatloaf includes 2/3 of a cup of breadcrumbs for every 3/4 of a cup of milk. A meatloaf to feed 20 people needs 18 cups of milk. How many cups of breadcrumbs are needed? The ratio of breadcrumbs to milk is 2/3 to 3/4. When a ratio is made up of 2 fractions, you can multiply by a whole number to make the ratio consist of whole numbers. So with this ratio, if we multiply both terms by 12, we get a whole number ratio of 8:9. To solve this proportion, let's use a double number line, like this. Let the top number line be for breadcrumbs, and let the bottom number line be for milk. On the first tick mark, write the basic ratio, 8 here and 9 here. Now begin scaling up by adding the appropriate value from the ratio. 8 increases by 8 to get 16. 9 increases by 9 to get 18. What we want is 27 for the value of milk. So scale up again. 16 increases by 8 to 24. 18 increases by 9 to get 27. This is the proportional ratio we want. So for 27 cups of milk, the recipe needs 24 cups of breadcrumbs.